Okay, so let me explain to you what remainder theorem is. Remainder theorem is if you have x minus c then, so if you have an x minus c, like right here you have x minus 7, then the remainder is f of c. That's what the remainder theorem is. So if I say x minus c, that's my x minus 7. What does it mean to find f of c? What would c be? 7. So basically, if I have x minus 7, then if I plug in 7 to the equation, it's going to give me the remainder. That's what that means, okay? So what we did previously is, and I'm going to do it right here, we did synthetic division. So we knew we'd put a 7 here. I'm going to put a 1. I have a missing term for x squared, so 0, negative 37, negative 84, okay? We do synthetic division. And this here is my remainder. My remainder here is 0, okay? So now, if I plug in 7 to this whole equation, it would give me the remainder, which is 0. So let's go ahead and do that. So we have 7 cubed minus 37 times 7 minus 84. So if you put that all in your calculator like this, 7 cubed minus 37 times 7 minus 84, you get 0. So that's what the remainder theorem is. It's basically plugging it in and it gives you the remainder. Okay? So let's go to the next page where it says factor theorem. So factor theorem means this. If I take my x minus c and I use the remainder theorem and remainder is 0, then that means x minus c is a factor. So x minus c is a factor of that polynomial if and only if f of c equals 0. All right, so let's take a look at this. Let's look at this first one here. Let's say I just use that remainder theorem and I plug in negative 1, my c. So if I plug in f of negative 1 into here, make sure you remember to use parentheses. Let's see what your answer is. So we can do mental math here. This gives you negative 1. 31 times this negative 1, two negatives will give me a positive 31 plus 30. Well, this gives me 30 plus 30. This gives me 60. Is this a factor? No. Okay, now let me show you a synthetic division since we have a remainder. You don't have to write this part in your notes unless you want to. So if I take negative 1 here, and let's see, I put 1, I have a missing factor for x squared, so I'll put 0, negative 31, and 30. You see how I get 60? So you can choose to either do synthetic division to see if it's a factor or just plug the number in. Okay, so this one doesn't work. So let's go to x minus 5. All right, so let's go ahead and Do you want to do synthetic division or do you want to plug it in? Okay, so let's plug in. Let's find f of 5. So I'm going to plug in 5 here. It's not negative, so I really don't need to put in parentheses. What's my outcome for that? 0. So if my remainder is 0, then it's a factor. So this one is a factor. The last one here, I'll go ahead and do synthetic division. So we'll put -1, 0, -31, and 30. Oh, that's a positive one. My remainder comes out to be 0, so this is a factor too. And that's all you're doing. Is it a factor, yes or no? And that's your factor theorem, is if you plug it in, if f of c equals 0, then it's a factor. Or if you use synthetic division, it's the same thing. All right, so let's look at this next one here. This is factoring and finding zeros. Remember what I said to make sure that you read the directions. So it says use the factor theorem and the given binomial to completely factor the polynomial function, then give the zeros. How many zeros will I have? 3. So x is going to equal 1, 2, there's my 3 zeros. This is a remedy to not forget this first 0 that's actually given to you, which is going to be what? -3. So let's put the -3 there. Now, you're not going to plug in -3 because you need to factor everything. Okay, so -3 plugging in just tells you if it's a factor, yes or no. It's your only purpose for plugging that in there. Okay, which we're going to use that tomorrow. So let's go ahead and use synthetic division. So we have 1, 3, -4, -12, no missing factors. All right, so now I'm left with x squared minus 4. So let's say they ask you to list out all the factors. Well, you would have x plus 3 would be one of them. And then this gives you x squared minus 4, which factors to be x plus 2 and x minus 2. So in the future, it's going to say, write out all the linear factors and then find the zeros. So that would be all your linear factors. And to find the zeros, that gives you -3, this would give you -2, and this would give you +2. You can put plus or minus 2 like that, but like I said, since I've been doing this for a long time, I've noticed that a lot of people will leave this out. So the remedy for that is to put this here to make sure you have 3 solutions because your highest exponent is at 3. Okay, let's do one more together. Let's do number 7. Now, if I look at number 7 right there, do you see something you can factor out right away? I would just go ahead and take that x out right now. Okay? How many zeros are you going to have? 4. Do you already know what one of them is going to be? 0. Because you set that equal to 0. You also know another one, which is what? This -5 right here. So now let's go ahead and take -5, and we're going to put it in this one right here. So now this gives us 1 less than the 3, so 3x squared minus 10x plus 8. So right now, if I was going to write my linear factors, I would have f of x equals the x plus 5, and then I'm going to factor this. So it's going to be 3x and x. Negative times positive. The signs are going to be the same. So that'll be a 4, and this will be a 2, because negative 4x, negative 6x will give me the negative 10x. So now if I solve, that's my 0, that's my negative 5. This would give me positive 4/3, and that would give me 2. And those are my 4 zeros, my solutions.